up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. Network performance issues can be frustrating, leading to slow speeds, connectivity drops, and application failures. And as an IT professional preparing for the CompTIA Network Plus certification, you must understand how to diagnose and resolve common network performance problems. And this video is going to explore various performance issues, including congestion, bottlenecks, bandwidth limitations, latency, packet loss, jitter, and wireless connectivity challenges. And by mastering these troubleshooting techniques, you can enhance network efficiency and ensure seamless communication across wired and wireless infrastructure. All right, so let's begin by talking about some common performance issues, and we're going to start with congestion and contention. So network congestion, this occurs when too many devices compete for limited network resources, leading to slower performance. And the common causes are excessive network traffic from high bandwidth applications like video streaming and large file transfers, insufficient network infrastructure to support peak loads, and multiple devices sharing a limited bandwidth connection. And to fix all of this, you can use network monitoring tools like Wireshark, SolarWinds, and PRTG to analyze traffic patterns. You can identify and prioritize mission-critical applications using quality of service. You can upgrade network hardware such as switches, routers, and network interface cards. And you can implement traffic shaping and bandwidth allocation policies to prevent bottlenecks. And speaking of bottlenecks, so a bottleneck, this occurs when a network component like a router, switch, or a server limits overall network performance. And the common causes are outdated or underpowered hardware, high CPU memory utilization on network devices, and insufficient bandwidth for connected devices. And to go about fixing all of this, you can check device utilization, such as the CPU, memory, and disk input/output using SNMP monitoring tools. And you can upgrade network equipment like replacing fast Ethernet with gigabit Ethernet. You can distribute workloads across multiple network paths like implementing load balancing, or you can implement VLANs to optimize traffic flow. All right, next we have bandwidth and throughput capacity. So bandwidth, this is the maximum data transfer rate of a network connection, and throughput, this is the actual data transmission rate over a network link. And the common causes of low throughput are as follows. So you have network congestion or bottlenecks, poor quality cabling or hardware faults, or high network load during peak hours. And to fix all of this, you can run speed tests using tools like iPerf or speedtest.net. You can identify high bandwidth applications or restrict or optimize them. You can upgrade to a higher speed internet plan or network link, or you can replace outdated cables like upgrading from Cat5e to Cat6 or Cat6a. All right, next we have latency, and this refers to the delay in data transmission from source to destination. And the common causes are the distance between endpoints. So you could be dealing with an international connection that has a higher latency, network congestion or inefficient routing, or inefficient processing power on network devices. And to fix this, you can use ping or trace route to measure delay and identify routing inefficiencies. You can optimize routing paths by configuring BGP, OSPF, or EIGRP. You can reduce the number of network hops by implementing content delivery networks. And you can upgrade to low latency switches and routers. All right, next we have packet loss, and this occurs when data packets fail to reach their destination. And the common causes are network congestion or hardware failure, wireless interference or poor signal strength, or misconfigured firewalls and security settings. And to fix this, you can run packet capture analysis with Wireshark to detect drops. You can check network cables and connectors for physical damage. You can adjust firewall settings to prevent unnecessary filtering. And you can reduce congestion by implementing traffic shaping or quality of service policies. Next, we have jitter, and this refers to the variation in packet arrival times leading to inconsistent network performance. And the common causes are high network congestion, poor routing or network misconfigurations, or insufficient bandwidth for real-time applications like voice over IP and video calls. And to deal with this issue, you can use ping or jitter testing tools like Ping Plotter or VoIP Monitor. You can implement QoS policies to prioritize time-sensitive traffic, or you can minimize congestion by increasing network capacity or implementing load balancing. All right, so let's move on and talk about wireless network performance issues. And first, we're going to talk about interference. And within that, we have channel overlap. So, overlapping Wi Fi channels, this can cause interference, which reduces network performance. And some of the common causes are nearby Wi Fi networks that use the same channel and incorrect Wi Fi channel settings. And to fix this, you can use Wi Fi analysis tools like NetSpot or Wi Fi Analyzer to scan for congestion, or you can switch to a less crowded Wi Fi channel like channel 1, 6, or 11 for the 2.4 gigahertz frequency, or channels 36, 40, 44, or 48 for the 5 gigahertz frequency. Next, we have signal degradation or signal loss. So, weak or unstable Wi Fi signals, this can slow speeds and frequent disconnections. And the common causes are as follows. So, it could be the distance from the Wi Fi router or access point. It could be physical obstructions like walls, furniture, or metal objects. Or it could be interference from electronic devices like microwaves and Bluetooth devices. And to deal with this issue, you can move closer to the router or install additional Wi Fi access points. You can remove obstructions or reposition the router, or you can switch to a higher frequency band like 5 gigahertz or 6 gigahertz for improved performance. The next issue is insufficient wireless coverage. So dead zones or weak signal areas in large buildings or outdoor environments, they can cause insufficient wireless coverage. And some of the common causes are limited range of access points, incorrect placement of Wi-Fi routers, or a lack of mesh networking support. And to fix this, you can install Wi-Fi extenders or mesh network systems. You can increase transmission power settings on the access point, or you can conduct a Wi-Fi site survey to optimize coverage areas. Next, we have what are called client disassociation issues, and this is when clients are randomly disconnected from Wi-Fi, causing interrupted connectivity. And some of the common causes are poor signal strength, authentication failures, and MAC address filtering or security misconfiguration. And to deal with this, you can verify your authentication settings, making sure you're on WPA2, WPA3, Radius, or 802.1x. You can check your access control lists and remove unnecessary restrictions, or you can update your wireless drivers and firmware for improved compatibility. And then we have what is called roaming misconfiguration. And this is when Wi-Fi clients fail to switch seamlessly between access points, causing network drops. And the common causes are poorly configured handover thresholds, mismatched SSID settings across access points, and a lack of support for fast roaming protocols like 802.11r, 802.11k, and 802.11v. And to fix all of this, you can enable 802.11r or fast roaming for seamless transitions. You can ensure consistent SSID settings across access points, and you can adjust signal strength thresholds to optimize handoffs. So in conclusion, network performance issues, they can severely impact business operations, user experience, and overall productivity. Now, by understanding common wired and wireless network performance issues such as congestion, bottlenecks, latency, packet loss, jitter, and Wi-Fi related problems, you can effectively diagnose and resolve network inefficiencies. And so mastering these troubleshooting techniques is essential for IT professionals that are pursuing the CompTIA Network Plus certification and those working in network administration, cybersecurity, and IT support roles. Now, with all of that being said, let's do some check on learning. So our first question is, a network admin is investigating slow performance on a company's wired network. The admin runs a throughput test and finds that data transfer rates are significantly lower than the advertised bandwidth. What is the most likely cause of this issue? Is it high latency, packet loss, network congestion, or wireless interference? And the correct answer is network congestion. So network congestion, this occurs when too many devices are transmitting data over the same network path, leading to slower throughput and higher contention for resources. Even if the network has high bandwidth, congestion can reduce actual data transfer rates, and latency and packet loss, this can contribute to slow performance, but congestion is the most likely culprit in this scenario. And wireless interference, this would not affect a wired network. Next question. A company's voice over IP phone system is experiencing frequent call drops, delays, and poor audio quality. After analyzing network traffic, the admin observes high levels of jitter. What is the best way to mitigate this issue? Would it be to increase available bandwidth, enable quality of service settings, upgrade network switches to newer models, or disable encryption on voice over IP packets? And the correct answer is to enable QoS settings. So jitter, this occurs when packet arrival times vary due to network congestion or inconsistent routing. Implementing QoS, this prioritizes voice over IP traffic, ensuring consistent packet delivery and reducing delays. Now, while increasing bandwidth may help, it does not specifically address jitter. Upgrading switches, this could be beneficial in some cases, but it is not the most direct solution. And disabling encryption, this is not a valid solution as it does not impact jitter. And our final question, a network admin is troubleshooting a wireless network issue where users frequently disconnect when moving between different areas of a building. The admin suspects a misconfiguration. What is the most likely cause of this issue? Is it roaming misconfiguration, client disassociation, channel overlap, or signal degradation? And the correct answer is this will be roaming misconfiguration. So roaming misconfiguration occurs when wireless access points do not properly hand off client connections as users move between coverage areas. And this can result in frequent disconnections and reconnections, leading to a poor user experience. Channel overlap, this can cause interference, but does not directly lead to frequent disconnections. Client disassociation, this can happen due to other factors such as security settings. And signal degradation, this affects coverage, but does not specifically explain issues related to roaming between access points.